Today we are in the lab for another geopolymer video, and this time it is from my book. Hello everybody, my name is Patrick. I'm the author of by now a number of books about geopolymers. So this is for most people the most interesting one. It's about the formulation and introduction. This is the German one, and most people are not interested in too much of a deep dive. That's why I published them in smaller parts. So as you see, it's not too thick, so everybody can afford a copy. And the other ones I wrote, they are much more of a deep dive and they're a little bit more costly. But anyways, all of them are very affordable. So let's see what we already learned. So in the first videos about this, I showed you a number of recipes, all of them based on metakaolin, which is this white powder, but it can also have other colors like this. By the way, this is another fantastic one for geopolymers, and so this is the one we use. This is another good for geopolymers, and this is a geopolymer, a metakaolin, which looks almost exactly the same. And this one is not so good for geopolymers. The reason is the kind of chemical reactions, and it's a nice thing to say this because in chemistry, of course, it's always because of the chemical reaction. So what we already learned is a number of very basic geopolymer recipes. The first, I think, I published, like for everyone, is like for everyone in my videos, and I think on Facebook is kind of the ones published in the book, but they are simpler. So in the book they are more precisely put, and the numbers and figures are more accurate. So the first one was metakaolin plus a particular sodium water glass solution plus sodium hydroxide plus, of course, some water. The second one I showed to you was fly ash plus sodium water glass plus sodium hydroxide plus water. The third one was made from a stone called truss or tough stone. It's ground up stone. It goes like this, truss, plus of course sodium hydroxide, but I write it down so you guys can see it better. Sodium hydroxide, of course, because all of them are basic geopolymers, so alkaline geopolymers. And the recipe itself in each of these examples was 1 part by mass, so 1 gram, 1 ounce of metakaolin, 1 of sodium water glass, 0.2, actually it's most at the time a little bit more, but 0.2, I like to put it like this so you can memorize it easier, and the same amount of water. With the fly ash we have 3 to 4 parts, but also 1 part, 0.2, 0.2. The truss is a little bit different. It's 1 part, 0.5 parts, and that must be, no, 0.15. No, sorry, it's not 0.15, it's 0.115. Yeah, and about the same amount of water. And the one we want to have a look on today is not an alkaline one, but an acidic one. And it goes therefore like Mk plus phosphoric acid the 85% kind, plus of course no sodium hydroxide, but an equal amount of water, not equal, same amount. This is actually a preliminary test, meaning I don't know this particular Mk. I mean, I know it because I used it in other formulations, but I like to assume today I don't know about. That's why I plan to do it like this. Actually, very simple. No, there must be H2O. H2O, I hope this is not too messy. H2O, the recipe is also is stated as well in the show notes below the video. And yeah, this is our geopolymer recipe we want to try out, and it might be that we have to add more water to make it mixable. The one more thing, I don't take only like 1 gram. I want to try out 12 grams. Then of course 12 grams and 2.4 grams, right? 2.4 grams of water. So this is what we want to mix right now, and that's why we keep our recipe close and start. Of course, we prepared everything what we need in the lab. It is, of course, some goggles because of the acid. It is the scale. It's a little bit supply. Now we start over. So this is actually a small amount I mix today. In the future, I want to make videos for you guys with bigger amounts of concrete or material I mix, because I know everyone wants to make like huge samples, but this is again a small one I make. And yeah, let's start. First, I measure out the amount of metakaolin. I take the right one. Again, the composition I will state in the show notes. "12 grams. As you see, it's already a lot because this one is very, very fluffy and very, very finely ground. Beautifully. 12 grams Mk, 12 grams of acid. It's a clear acid. Sometimes they become a little, they get a little bit of a taint. That is the right term. They can become a little brownish. But if they are any fresh, they look like this. That means phosphoric acid, 85%. We need 12 grams. Phosphoric acid is way heavier than normal water, So you can do it using the volume of the material, but then you have to recalculate, okay? And that makes sometimes the thing a little bit more, not necessarily difficult, but you have to calculate more. In my book, it is stated how that goes in a short, but I think comprising manner. 12 grams. It's okay. It is distilled water. You can get it in the drugstore. This is the acid. I place it like this, so I don't make mistake. Of course, I have to prepare, or I have to mix in the water at first. As we all know, this is very important. At least with some acids, because the diluting of acid can be exothermic. And then when you drop in water in the acid, especially in phosphoric acid, that can become very hot, and then it can make splashes. So it's dangerous. Now we can add our acid, stir a little. Now we mix in the acid into the MK. Again, this is a simplified way to put it. So I find it very important that people have something with which they can start, make a little bit of this, I find, very interesting subject. Take this bigger one, mix in the water, the phosphoric acid solution, and give in the MK in smaller amounts. What we want to achieve is that all of the material comes in contact with our solution, no matter if it's acidic solution or basic solution. And that you can do way better when we do it in smaller portions. This one will be quite sticky, so quite hard. No, what is the right term? More like a dough, okay? Not so liquid. As you see, this is not working out so good, but it doesn't matter. We already prepared some new stuff. This one is from silicone. It's actually from the kitchen. They are very suitable for geopolymers. Now we try to give it a better mix. I think you can see, if you do it really thoroughly, then you can break apart all the clumps and give some more. Now you can see it's very sticky. It's actually already like a dough. But it doesn't matter, because we want to make a preliminary test. Go to the spatula. I do it like this. And now I start to mix in the remaining of the MK. This time I like to add 1. Has a good consistency. Okay. Now I managed to put it in its container. I will give it a little bit. So I wrote down everything what I need to know. The date, of course. It's the exact recipe, 12 grams MK, 12 grams H3PO4, 6.4 grams of water, and I write down the time of the day, which is 12:20. Okay, right now I don't have a fitting lid. No problem. I take just a little bit of the foil and cover it so it cannot dry out, as this is always important for geopolymers, at least in this stage of experiments. Now we set it aside. We clean the lab. The stuff needs to be washed, rinsed with water. So one thing remains to do. I found this sample from before. Its recipe is a little bit different from what we did. It says I added a mixture of 5 parts acid to 2 parts water, and of this mixture 8 parts to 5 parts MK. And what came out is this. It sounds more like broken glass. It has quite some sharp edges, and I didn't knock it in the end, tuck, 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 and that's why it kept its shape. Anyways, there's a good chance that the hardening process might take some while. Yeah, this is basically the process of making an acidic geopolymer, and I hope you liked it. I hope you guys liked it. As I said, in the future I want to make videos in bigger amounts, like we will do it for concrete or mortar. This recipe was taken out of this book, and yeah, I hope you liked it. Give it a like, share it, subscribe, and yeah, let us start a revolution in concrete, a revolution to the better. Have a nice day. Bye. Hello again, here in the lab. I did not look as I wanted to do it every 24 hours or so, but it took quite some while. I stopped, I think, at the third or fourth day. I write it like here, and yeah, but eventually they became hard and solid. It's the pure metakaolin, pure H3PO4 with some water binders. Here's the recipe written: MK H3PO4 and water. It's actually beautiful. It has really hard edges. Only the thin walls can be, so you cannot crush it. So the scratches are because there are scratches in the container. So each scratch in the container you later have on your geopolymer. So, and this is the recipe we use for this one. So as you see, although the recipe was not perfect, it is possible, but if you want to use this for an industrial process, yeah, it needs more development.